Our next panel is looking at the consumer experience. It's kind of a nice segue. We're looking at the consumer experience. I'm going to, let's see. Okay, so our next moderator is Erica Johnson from the University of New Hampshire Interoperability Lab, which has done quite a bit of work in the IPv6 arena. And she's going to lead the panel that's going to talk about the consumer experience.
Yes, thank you, Carol. Again, my name is Erica Johnson, and I'm the director of the Interoperability Laboratory at the University of New Hampshire, also known as the IOL. So today we're going to be talking and focusing on the consumer broadband transition. This is going to be a big challenge. Hopefully we'll be able to answer some questions for you today. We'll look at broadband strategies, also some testing strategies, and what has to be done. What's the time frame? What are we looking at here? So I'm going to introduce my panelists, and then we'll continue on from there. First, I'd like to introduce Chris Donley. He's the project director for network protocols at CableLabs. He has done a lot of work in the V6 space for the past 5 years, also in the Ethernet over DOCSIS area. He is very active in the IETF, and he also serves as the MEF Certification Committee co-chair. Next, I'll introduce Keith Stewart. He is a project manager and director at Brocade. He's responsible for Brocade's vision and direction across its application delivery family of products. Lastly, I'll introduce Alain Durand. He is the principal networking architect and software engineering director at Juniper Networks. Prior to Juniper, he helped the IPv6 deployment at Comcast. He also is highly active in the IETF, authoring numerous drafts and RFCs, as well as co-chairing working groups. So with this panel, hopefully, we'll be able to answer some of these basic questions. For example, how many customers will be affected by the transition? What do consumers have to migrate to IPv6? Do we really need IPv6, or can't we just do it with NATs? Who will be responsible for ensuring subscribers can access content? Is it going to be the broadband provider? Is it going to be the content provider or other? And when will equipment actually be production level ready? A lot of equipment vendors have said that they're gearing up for IPv6, they're testing, but is this production level? Is it operational today? So with that, I'm going to start off by discussing some of the testing strategies around consumer broadband and what's currently available today, and hopefully talk about future testing opportunities as well. To back up, the IOL has been testing data communications and storage networking protocols for the last 20 years. We base our testing on open standards, focusing on mostly IEEE, IETF, ITU, and others. Specifically, we've been testing IPv6 for the last 15 years. We've worked very closely with forum organizations such as the IPv6 Forum, as well as other organizations, to prepare for the transition and deployment of V6. So let's talk about the new IPv6 Forum CPE logo. Is everyone familiar with the IPv6 Ready logo? No? Yes? Well, the logo's been around for over 10 years. This is enabling end users to visibly see some progress with devices testing IPv6. So we started out combining or organizing ourselves as a logo committee, which is international, combining labs from around the world to come together and produce conformance and interoperability test specifications. This enables the equipment vendors or the manufacturers to actually test in their own house or at testing facilities and prove to the world that they are IPv6 ready. So we've started in early 2000s testing the base IPv6 protocols, progressing, adding more and more services like DHCP, IPsec, IKV2, and now we're about to launch the CPE logo in November of 2011. This is going yet another step to help the transition movement and help broadband deployments worldwide. So we are going to test the core, the basic V6 protocols for these CE routers, as well as look at DHCP test cases, as well as the CE router RFC, which just came out this year, which specifies the basic requirements for a CE or a home router. Along with the logo push in November, the IOL has been hosting interoperability test events throughout this year in order to help equipment vendors as well as operators and other laboratories push towards the deployment and get equipment vendors these logos. So how do we conduct the interoperability test events? Well, we host them for one, but we also invite and collaborate with many other organizations like the Broadband Forum, the cable industry, working with CableLabs, other equipment vendors to make sure that our test cases are validated and that they're the best tests and the most useful tests for these deployment scenarios. So during this week, it's a grueling week of testing and rearranging our test cases, maybe changing our procedures, and in the end, we would like to end with the goal of providing a logo in the November timeframe. Our next event is going to actually be in October to help pre-test for the logo. Along with the test events, we actually have a publicly facing website which lists the CE routers that are currently working on testing this test specification today and that are either past the tests or have been very close to passing the tests and working at the interoperability test events. And that can be found on the IOL's website, iol.unh.edu. So along with working very closely with the IPv6 forum, the IOL also works very closely with the NIST and in regards to the USG v6 test program. We have been working with NIST for the past 3 years on developing a IPv6 test program that will satisfy US government agency procurements. Now, these are protocol test cases. They're not feature, they're not functionality, they're not the end-all solution to testing, but it's a start, it's a beginning. Agencies, along with operators, along with any enterprise that is deploying v6 should obviously do more testing in their own labs, test the features and functionalities of equipment, test that their services are going to be maintained high quality, and that content will be accessible. But protocol testing is the #1 first step that everyone should be looking to. And that can be satisfied by the USG program or the IPv6 Ready logo program. So the structure of this panel is I'm going to invite each panelist up and they're going to provide a point. We're going to leave time for other panelists to comment on the speaker's point. And then at the end, we'll open up the floor for general Q&A. So with that, I'd like to invite Chris Donley, who is the project director at CableLabs.
Thank you. Today we talked a lot about what is the business case for IPv6. So let me walk through some of this. Let's talk about address sharing. As you've heard this morning, the supply of IPv4 addresses is running out. At some point in the near future, ISPs will not be able to get any new IP addresses. Unfortunately, we're seeing continued growth in subscribers and new services and new devices within the home. And very rapidly, the demand for IPv4 addresses is going to exceed the supply. So this is where IPv6 comes in. As IPv6 comes online and customers have devices that support it and the content that they're looking for supports IPv6, you will see the demand for IPv4 gradually start to decline. However, at least for a period of time, the demand for IPv4 is still going to be greater than the supply. So service providers do have some options. They can purchase new addresses. There was a recent purchase. Microsoft bought 600,000 addresses from Nortel. So there is a way to buy new addresses. And some service providers can also reclaim addresses from other places within their network to use for customer-facing services. Some providers will have more flexibility than others for this reclamation and may be able to satisfy their own customers' internal demand. But looking at the internet as a whole, there will be a portion of subscribers that cannot get their own address. And that's where address sharing comes in. So what happens when we share an IPv4 address across multiple subscribers? If you have web and email traffic, it's going to behave normally. CableLabs has been doing some testing of NAT 444 within our labs, where we add an ISP carrier-grade NAT device in front of a home router supporting NAT. As you'd expect, the basic services will work as they have normally. However, once we start getting into more advanced applications, we start to see issues. Video streaming performance starts to be degraded. What we've seen is that there is increased buffering time when starting a new video stream going through this topology. Also, when you share multiple streams going through certain devices and certain home gateways, we've seen that as soon as the second stream is added, in some cases, we start to see a lot of rebuffering immediately to the point where at least one of the streams becomes unplayable. And finally, peer-to-peer traffic, which is peer-to-peer file sharing, but also some over-the-top voice over IP, some different types of internet gaming, and other services where the subscriber is acting as a server. There was a question in the previous discussion about using NAT as security. Well, in this case, it functions almost in that way, preventing some new incoming connections from getting down to the customer device. So a lot of peer-to-peer type traffic is going to be dropped. However, the IPv6 traffic does not go through an ISP NAT device and goes directly to the IPv6 internet. That traffic behaves as you would expect, not just the web and email, but the video streaming and the peer-to-peer and all other traffic goes through as normal. So in conclusion, the IPv4 traffic will pass through the ISP NAT and offer the subscriber a diminished quality of experience. But IPv6 traffic has a direct path to the internet and will offer a better experience to the subscriber. Thank you.
Any comments?
Yes, I have two comments. From a diminished experience perspective and a performance, it really depends on how much silicon we forward the problem. Because we can build NAT that will forward packets without creating any delays, just a router after all that swaps some headers. So there's some hardware solution that can be applied to this issue. The second about the peer-to-peer type of application. There's some work that we're doing in the IETF and the PCP working group, the Port Control Protocol working group, where application can dialogue, negotiate with the NAT to establish their outside presence and essentially re-enable those server-style applications like peer-to-peer. So, like we have seen in the mid-90s, when applications started to evolve around the NAT in the home, I will not be surprised to see application evolving around the NAT in the carriers.
Yes, I agree with that, and we've already seen some improvement on certain applications. A combination of new application layer gateways within the NAT devices and protocol work being done by the content providers has made some improvement in the quality of the NAT over the past year or so. But it's still not the same level of experience that we're noticing with IPv6. And at some point, we have to think, where are we going to spend our energy? Are we going to do it fixing NAT for IPv4, or are we going to move everybody to the better experience on IPv6?
I think that makes sense, and that actually leads into exactly what I want to talk about. So I'm up next. Awesome.
Next speaker is Keith Stewart.
All right. So the comment that I was going to make there, Chris, is I wholeheartedly agree with what you were saying, that while I believe that some of the comments earlier that said translation is not ideal is absolutely the case, I think the pragmatic reality when we look at some of the business drivers is we are going to need translation to help us manage this transition. And while there will be environments where we want v4-based translation as a key part of that solution, I would argue that the destination of v6 is the place we got to put our energy. And so if we need to do translation, we should be focusing on how we manage a v6 style translation first before we look at a v4 translation. And let me show you a little bit about what I mean. I think we've heard countless times this morning on the ultimate destination, and I think there is no debate in this room on where we need to go. Right? We need to migrate the global network infrastructure, internet and private infrastructure, from a v4 only world to a full dual stack world. Now, at some point in the far-flung future, when likely none of us still have jobs anymore, perhaps IPv4 as we know it today may go away, and perhaps on some of the more aggressive forecasts it'll go away even sooner than that. But I think the next natural milestone is a two-protocol world, and that's what we got to aim towards. Now, as we talked about over and over again over the course of the day, the business case in order to get there oftentimes is perceived to be murky. Right? In absence of a killer app or a driving force, we're left with either a negative business case that says do it because we're running out of addresses, or a much more murky positive case that talks about potential things like the networking effect that suggests when we have all of these additional devices online that new goodness will come out of that. But it's tough to get a decision maker to really allocate near-term budget against those kind of models. So the suggestion that I would put forth is we need to take this problem and break it up into smaller projects, right? And as we think about the consumer broadband element of this and whether we're on the carrier provider side of that or the content side of that, I think the argument holds true. We need to break that up into individual component projects that can motivate a particular decision-making, a decision maker to fund a particular project. We've talked earlier on today, I think in the enterprise session, about v6 presence. That's clearly the first point. How do I offer services to v6 only clients to get my step out there? I think as we take a look more at the broadband side of the equation, dealing with this protocol islands problem is an area I want to spend just a moment talking about. And then the third one is, in the largest sense, dual stacking, and I use the word here loosely, your core. Now, if you're on the carrier side, we heard earlier around NTT and how their views on what 2010 was in terms of carriers upgrading backbone. If you're an access provider or if you're an enterprise, that may mean doing your internet edge. But starting with that core component of your network and building out from there is clearly the right long-term solution in order to get there. I would argue, though, that in order to pick off some of these projects, if you're dealing with net new upgrades of infrastructure, you want to go straight to the dual stack componentry. But in a lot of cases, you're going to want to take advantage of technology that enables you to reuse existing assets. That's how we diminish the cost to some of these early projects in order to get them moving, start getting organizational capabilities in v6 growing, to then start continuing down this path to dual stack. One of the conversations I have with a lot of the people I talk to is about a 3 to 5 year plan towards IPv6, and that critical first year is all around building up experiences and organizational capabilities. So whether that be by managing your external presence, or whether that be as you are hitting this exhaustion point, focusing specifically on those areas that enable them to access new services, things like translation services, NAT6.4 or 4.6 style services that allow you to take some of your existing v4-based infrastructure and make it available on the v6 network, I think is a key step, a key tool in our overall tool belt as we tackle this. So let me show you a specific example pulled out of a broadband environment. In this case, we're talking about a provider that's got a series of v4 only enabled set-top boxes up on the upper left there. Right? These are devices that may not even be fully v4 capable. One provider that we've worked with has got a set of devices that don't even truly do DNS. They've got their own little hacked up name resolution capability built into them. These are platforms that simply cannot do IPv6. However, the economics of doing a truck rollout to each of those subscriber sites to upgrade that physical set-top box is simply incomprehensible. There's no possible way that that's going to happen. Those devices will be upgraded as the subscriber rolls over their service. So if that provider is moving more and more of their infrastructure towards v6, 2010 is a v6 backbone, 2011 and 2012, new video on demand style services, over-the-top premium services that are going to be delivered. That infrastructure, rightly so on its natural upgrade cycle, is being built out to be delivering v6 services first and foremost, and v4 services as a back end. Now this can get even a little bit more challenging for some of the larger providers because some folks have chosen historically to manage their subscriber network with RFC 1918, i.e. private addressing space, which has worked fine historically when all of the service delivery elements lived within that network profile. But if you've now got, say, a New York market that's using 10net and a Los Angeles market that's using 10net, and you now want to offer over-the-top services, I now want to be able to uniquely identify my subscribers based on addresses. But I can't do that because if I've got shared services trying to cross back into common addressing, private addressing space, that's going to break. There's no ability to go and uniquely identify those systems. The solution that this provider has worked with us on, as have a number of others, is to build a v4 to v6 translation element. Now, for those of you who are less familiar with the NAT6.4 standards here, there's both stateless and stateful translation, and it really does depend on whether you're talking about v6 only clients talking to v4 resources or v4 only clients talking to v6 resources. In this case, it's the latter. But you've now created an ability by appending prefixes for those subscribers to get out of that island, if you will, of v4 only and into the new world of v6 only or v6 dominated resources. The exciting benefit that comes as a result of this was that overlapping IP address problem that I mentioned. For some of us, it took us a while to wrap our head around how many times the v4 entire internet can fit inside the v6 addressing structure. So simply by appending a different prefix on the front end of those infrastructures, you can effectively get to uniquely identified subscriber IDs just by prepending on a /96 on top of the existing private IP space. So there's some secondary benefits that have come as a result of this. Now, while it's not in this particular slide, you can reverse this around. We've worked with a hosting provider as well on a similar use case, but for them the problem set is reversed. They've got, they're dealing with exhaustion as their primary motivator as a movement towards v6. And in that case, their issue is they need those clients to be able to access legacy v4 services that exist in their infrastructure. So you can run a translation element in order to get new onboarded v6 only clients over into v4 infrastructure. The final point I wanted to make before I stopped on this was to say a key thing, and it was hit upon earlier when we were talking about voice, key thing to remember anytime we're looking at these interim translation steps towards dual stack is that as we've learned in the security use cases historically, layer 4 and layer 3 and layer 7 are all integrally tied in real world application behaviors. So let me give a specific example. In the hosting provider that I was talking about use case, in that environment, they need the ability to uniquely audit individual clients as they cross over a translation boundary. The way that they chose to manage that scenario was to inject the client's source IP address in the before translation use case up into the HTTP headers in the after translation use case so that their HTTP infrastructure can then go and audit which clients are accessing. That's one example, and a pretty straightforward one, that shows how layer 7 capabilities are tied into what you're doing at layer 3 and layer 4 when you're trying to manage these translation use cases. The SIP example that we talked about earlier on this morning in the voice over IP conversation is another really good example of that. And so as you think about some of these smaller projects that can get you started on moving towards V6 or help you deal with the more economically intractable parts of your network, moving them to V6, I would just encourage you to think about the particulars of the application, not just the layer 3 protocol elements, to make sure that you are positioning yourself for success.
Thank you. Any comments?
I'd like your discussion about a phased approach. I think that however we go forward, you'll see many different steps in the transition. In the near term, though, we're still limited by content and also on the customer side by IPv4 only consumer electronics, as you're showing in your picture with the set-top boxes and the TV sets and Blu-ray players. So in addition to the NAT6.4 translating from the V4 clients to V6 servers, we, as an interim or as a first step, we probably still need to support V4 clients connecting to V4 servers through the NAT. And then a number of providers are also trying to offer a native V6 path as another step in that transition. Yeah,
I think those are good points. I think that I would come back to the comment that I think was made a little bit earlier that said, you got to get started. You got to pick a project. I think that's probably the most important thing, is to pick a tractable project and get started and get some successes to then build. Thanks.
Next, we have Alain Durand.
Thank you. So I'm going to take a more pessimistic perspective on this. Okay, we are running out of addresses. INR ran out in February. APNIC ran out in April. I've heard that IRN is going to run out before Christmas. So we ran out this year. And we're talking about steps that will take 5-10 years to take us to IPv6. What do we do in the meantime? Because if I have to run a network and I'm growing, I need to do something today. I cannot wait 10 years to have all those steps in place. So that's what I'm really going to talk about today. What do we do in the meantime? If I look at what's happening in home networks or in enterprise networks, there are a long tail of legacy device and legacy application. Talking about Windows XP, there are many, many enterprises who still run XP in the IT department as the base. This is not an IPv6 operating system. I'm talking about the TV sets. I was explaining at lunch about a nice TV just before Christmas, very large, magnificent picture, internet ready. Well, it's IPv4 internet ready. And I tried to upgrade the firmware. I think I'm fairly savvy with computers. It took me 4 days with a customer service department of a TV manufacturer to actually do this, and it was not pleasant. So I don't suspect that many of those TVs will ever be upgraded. I'm talking about this point-and-shoot camera that can upload the pictures straight to your social network, Facebook, Flickr, YouTube. All those devices that exist today by the million are IPv4 devices. So if I offer only an IPv6 service, I cannot use those devices. So that's really not a starting point. Now, even if those devices are V6, there are applications that are V4. Example is Skype. Skype may be evolving in the future, but today it's an IPv4 application. So if I have Skype running on my cell phone, and my cell phone is an IPv6 cell phone, it doesn't work. Or if I have Skype running on my laptop that is connected through Wi-Fi through my cell phone acting as a MiFi, like local access point, and then I try to go to the internet, if the cell phone has only IPv6 and my laptop is a V4 laptop or a V6 laptop with V4 Skype, it doesn't work. So, and when, of course, I go to the rest of the internet, the content out there today is only less than 1% v6 switchable. So from this, it seems very clear that service provider in this period that can be 5 or 10 years long, or maybe more, must maintain some form of v4 service. It's not going to be the same as it is today, but there has to be some form of v4 service. So simply doing v6 is not going to solve a problem. They are not compatible, period. So back in 1992, 93, 94, when we started to implement IPv6 and develop the standards, at the time, maybe there was a few million devices on the internet, and we thought the internet is growing exponentially, so who cares about a few million devices? In 12 months' time, they will be gone. Well, now we have a few billion devices. It's a different problem, and we cannot simply abandon them. So we need to keep this v4 service. So if we look at the right-hand side of my diagram, I try to play this as an opera to make it a little bit lighter. But prelude is, OK, we run out. First thing is the VLAN comes and this IPv4 NAT and somehow solve the problem. Most of the service providers I talk to have some IPv6 plan. They also have an IPv4 NAT, carrying NAT plan. And this is already deployed. My cell phone is behind a NAT here. There are countries in Europe, Eastern Europe, where you have already those double NATs in place. Countries in Japan, places in Japan, where it's also the case. This is something that is happening now, period. What's happening after that is the network gets more complex. When you want to deal with, we heard this morning about geolocation, that's one of the cases. When you want to deal about lawful enforcement agency queries. Who was using IP address 1234 yesterday? Well, maybe 100 people were using that address. So first tell me exactly at what time yesterday. Is it at 12:05 or at 12:03? Maybe different people. And then tell me which port number they were coming from. Then I can maybe go in my log, in my NAT, and tell you who was there. If not, I cannot help you. There are issues about DOS mitigation. Where today, when there's an attack, DOS attack, what you do is you take this address, you put a filter, and you dump all the packets. Well, if there are 100 or 1,000 people behind this address, sure, you're going to take the bad guys away, but you are going to take out maybe 99 other people who have done nothing for you, against you. So that's not good. So if you are, for example, a bank, and a local bank that serves your local neighborhood, if you take 99 people away, you may take away your entire customer base by filtering out one IP address. And that's really not good. So all those problems are going to be more and more difficult to deal with over time. So this pain increase. And that's really where this IPv6 story comes to help. It's not to solve the v4 exhaust problem. It's really to solve this complexity that is created by the notion that we are going to share address, that is created by the break of the paradigm IP address is a customer. We are going to lose that this year, at the end of this year. And IPv6 will help us to recover this paradigm. So at that point, if we have content available and service provider offer v6, then we have potentially v6 traffic. So a packet that goes over v6 is a packet that doesn't go over NAT. And if a big top 5, top 10, top 100 content provider have v6, and you as a service provider offer v6, you can be sure that you can have maybe 80 or 90% of your traffic volume that will shift over v6 very quickly. But you still have another 10% that is v4. And that traffic will require to maintain this IPv4 NAT infrastructure. Simply, you may have a cap and grow strategy here so that you don't keep investing there. And as a good opera, at the end, of course, the VLAN will die, and, but it may take very long. Sometimes it will take maybe 5, 10, 20 years. I don't know. So let's look a little bit at some strategy and the economic aspect of this. So we heard about doing some IPv4 internal reclamation. That's probably the simplest thing that an operator can do to try to reclaim some addresses and get a new source of v4 address. In some cases, the gain can be really large. In some cases, they may be small. There's some OPEX associated to that. I've heard about an IPv4 address market, and Chris was mentioning the transaction between Nortel and Microsoft. Well, that transaction is public. was putting a value of $11.5 per IP address. So today, if you go to Aaron and you ask for IP addresses, it's fundamentally free. You pay a marginal nominal amount just for maintaining the record, but you don't really pay per IP address. And depending on how big you are, you may pay more or less on your membership fees, but it's a very small amount. Here we are talking about significant amount, $11 per IP address. So if you have 10 million customers times $11, that's a lot of money. But still, I do believe that this number is very small. What you have to compare it is not so much with what you were paying before, which was 0, but actually to how much money, how much revenue can you generate with this IP address. So I have a cable service at home, and I could have fiber or DSL will be about the same. My internet bill, combining telephone and video and internet, is a couple $100 a month. Well, maybe I'm on the high side, but the average is about $100, $150 from what I understand. So this IP address, or couple IP address, generates something like $100, $200, or $300 of revenue per month. So if you compare this to a one-time cost of $11, that's nothing. So very probably this price point here is going to go much, much higher than that. How much exactly? I don't know. If, as Chris mentioned, the demand for IPv4 address at some point drops because IPv6 takes off, yeah, maybe going down. But if you still need those v4 addresses anyway for the long tail, maybe not. So if you put NAT, category NAT in place, what you do is instead of using one address per customer, you may use one address per maybe 100 customers or 1,000 customers, depending on how you scale this thing. So now you can distribute this cost across that many users. So it makes it a little bit more manageable. But when you do that, you somehow created a downgraded service. Because I agree, I mean, NAT is not perfect. We try to make it as little impacting as possible, but still create some impact. So from a customer perspective, being behind a NAT, from a carrier or not being behind a NAT, there is a difference. So how do you manage this difference, especially in terms of perception with your customers? So in practice, that means which customer do you put behind a NAT, and which do you put behind a normal service? So is it only NAT for the new user? Well, that sounds like a logical thing, okay? New user, new contract, it's behind a NAT. However, most of the time, your new users are the ones who bring you the most revenue. Why would you put the degraded service to the user that brings you the most revenue? May or may not make sense. So you may want to do the exact opposite and put your legacy users who bring the least revenue behind the NAT, reclaim those addresses, and use those addresses for the users that are the new user at a higher level service, at a higher level revenue per IP address. And this is really this notion of RPIP, so average revenue generated per IP address, that as a service provider you need to look at so that you distribute the addresses where they bring the most revenue. It's a simple economic sense. But still, what do you do for those users that you decide to put behind this category NAT? What if they don't like it? What if there's a backlash? Do you have an opt-in or do you have an opt-out mechanism? Or do you have maybe a new tier of service where you explain, okay, you're going to share your IP address, but in exchange, you will pay maybe $2 less a month, something like that. So all those economic questions need to be answered. Now, you do IPv6 in there also to make sure that at some point all those problems will go away. That's really what it is. It's an insurance policy to make sure that these issues will go away. The fundamental problem with V6 is that if you do it as a service provider and you put all the money that is necessary to replace everything, you don't get much benefit until everybody else in the industry does it. That's this chicken and egg problem that we have been talking about for 20 years and looking for the killer app that we never found. It seems that now folks are going to go that route, so there's at least a common synergy among operators to go there, so that's good. The question now is, there's this little piece of equipment, the home gateway, CPE, wireless router, there are many names of this thing. this little box that you connect behind the cable modem or behind the CP, behind the DSL line or fiber line that you are going to test, okay? This box today, in 99% of the cases or more, is an IPv4 box. And it needs to be replaced. Costs anywhere between $50 and $200, depending on the box. All of them on the planet need to be replaced. Who is going to pay for that? So I've heard a lot of service providers saying, OK, we will give a new box to the new user. That's fine. But if we do that, it's a slow rollout. It may take 15 years, or at least 10, 15 years to replace all the boxes. If you want to be more aggressive and get IPv6 sooner, there has to be somebody who is going to pay for the replacement of those boxes. And I really look at this as the #1 item that will make or break the deployment of IPv6. There are some other technical problems. Of course, some users may think that V6 is slower than V4, but this will go away. It's a smaller issue. And that was it.
Any comments?
So on this cost per IP address conversation, how high you've raised the question, how much higher do you think it'll go? What's your sense on order of magnitudes there, right? $50, $100, $1,000?
Well, OK, let's say that you have an average of $100 revenue per month for a customer, and you have one IP address that generates this. Let's say that you want to save like $1 to enable this $100 per month. That's $10 per year. So if you are looking at something like a 10% return on investment, that value the address at about $100. So I will not be surprised if we go that high.
Thank you. Before we open up to the floor for Q&A, we had a extra speaker that was not able to show, so we have a little extra time. Alain, you can sit down. I just have a couple questions that I'm going to ask the panelists. One question that I'm really curious about is who is responsible for ensuring that the content and the subscribers can access the content and that they'll have a high quality of service?
I think everybody is responsible. This is a whole ecosystem issue that we need to make sure that the ecosystem is engaged. So that means that the content provider needs to be offering content over IPv6. The service provider has to be offering IPv6 access. The customer has to have an IPv6 home router, as Alain was discussing. And consumer electronics need to be available that support IPv6 so that the customer can get the best quality of experience all the way across the network.
Yeah, I guess my perspective on that is you got to tie it back to who has the most economic stake in the customer's experience with their content, which most of the time starts with the content provider. Right? Their business is so directly impacted by individual subscribers' ability to access. So I tend to start that conversation there. However, as you start going down the long tail, to your point about the number of different sites out there, further down that tail as you get away from the sites that are so directly tied into their own organization's revenue stream, I think the responsibility starts to shift back towards the provider that's providing the service to the end customer. You know, yes, my local real estate agent has a stake in their website being available to the broader consumer base, but it's hard to complain to them. It's relatively easy to go and complain to Google or Facebook or Yahoo or whoever. Hard to complain to the local real estate. And so I suspect as you go down that long tail, it's the provider who's going to end up being stuck with responsibility for that experience.
I will tend to agree with that last point because users most of the time will not even know that there's IPv6 or IPv4 or that there's an IPv4 exhaust problem. All they want is to access the content. And if for some reason they cannot access the content, they're going to complain. So who do they complain to? Well, there's no 1-800 number that you can call for Google. So there's a 1-800 number that you can call for your service provider. So most probably they will call their service provider. Exactly. So they will be at the front line of this issue. Yeah. So as such,
Google will complain because Google will know immediately that they've started losing traffic, which means they're losing ad revenue. So that, again, I think that's why at that big end of the scale, those guys will have stake, not because the subscriber's going to complain, but because they'll so directly see the impact to their daily business model.
I will agree with that. But there's a study that we made when I was still on my previous job at Comcast, where we're looking at how much content was available over V6, and we look at the Alexa top 1 million, and we ranked this on the top 10, then the top 100, the top 1,000, etc. And what we observed was that there was a direct correlation between how popular the content was and how likely it was to be IPv6 ready.
Makes total sense.
Okay, we have just under 15 minutes, so I'll open up to the floor.
Question for you, Erica. You mentioned in the last 10, 15 years, you have, University of New Hampshire has been testing interoperability on IPv6. Can you name maybe top 3 issues that you have run into in terms of the interoperability and you have been able to make recommendations in solving those issues?
Sure, actually, so there's been many issues from the beginning when we started testing in the early 2000s, when we created something called the Moon V6 Test Network. And this was a collaboration between the Department of Defense and multiple labs around the nation that connected and test over a wide area network. And we found many issues with early implementations in terms of just their base stack, IPv stack implementations and duplicate address detection and path MTU issues. Now, over those 10 years, we've been able to write white papers on these issues and made recommendations to not only implementers but also deployers. And since then, a lot of improvements have taken place. Recently, we are going to open up that network again and create a son of the Moon V6 network, so to speak, named Bound V6 to honor the late Jim Bound. And hopefully, again, we can address some more interoperability issues on a real scale environment, not just a point-to-point interoperability test case scenario that we're currently involved with the logo program type testing. But we'll be able to create an environment where application vendors will be able to connect and ensure that their services will be able to work over the V6 environment in a dual stack and native, and also if they'd like to test out transition mechanisms as well. And we'll be able to write down our findings and make more recommendations moving forward.
There was a chart in one of the presentations showing the adoption of IPv6 leading to a decrease in demand for IPv4 addresses. But all of what we've been talking about is dual stack, which requires an IPv4 address. So I was wondering, can you address what is the status of all the commonly deployed consumer operating systems operating in IPv6 only mode, i.e., when do we see that actual decrease in demand for IPv4 addresses, because we don't have them on the computers anymore?
Actually, I will say that even that will not decrease it. Because
I'm sorry, I didn't understand.
Even if all the devices and all the applications on the planet were to be made IPv6 only capable, this will not decrease the number of IPv4 addresses you need. The number of IPv4 addresses you need to run your network is essentially a function of a carrier grade NAT that you deploy. So if you have a carrier grade NAT that translates V6 to V4 or V4 to V4, it will actually make no difference. You need the exact same size of address pool in there to access the remaining of the internet. So what actually makes a difference in the number of addresses you need is the number of flow that you need to translate. And that is a function not on the client endpoint, but on the server endpoint. So if you want to reduce that, you need to have more content made available over V6.
Now, as the more content is made available over IPv6, when a dual stack host sends out a DNS request and gets back both a v4 answer and a v6 answer, it will choose the v6 host to connect to. So over time, as more content becomes available over v6, you will start to see that shifting. v4 is going to be around for 20, 30 years, at least on certain networks. As I think John Curran mentioned earlier, if you have an IPv4 printer, you're not going to upgrade it to IPv6 just for IPv6. But as you start going to the bulk of the content, the Googles, the Yahoo, et cetera, you're going to see the demand to the v4 sites starting to diminish.
Okay, but what I'm trying to get at is, as long as we're going dual stack, we've got IPv4 addresses on the machines. So how does going dual stack deal with the IPv4 address exhaustion? We've got no more IPv4 addresses. How do we do dual stack?
Yeah, so I think it's a really good question. I think there's a couple of pieces there. One is we got to make the distinction between unique v4 addresses and reused v4 addresses, which is, I think, Alain's point there, that for some set of traffic or some types of flows, there isn't necessarily value in having a unique v4 address, and you can start to almost regurgitate that kind of addressing, which implicitly reduces some of the demand structure there. Now, the follow-on to that is at the point in time at which the crossover pain of having some part of the network take a v6 only endpoint and allow it to access what at that point will be legacy v4 infrastructure versus dealing with the management and update of an individual second stack on that endpoint, that's where that crossover point starts to occur. When you're able to say, rather than reuse one of these double or triple regurgitated v4 addresses and deal with the pain associated with that, I'm going to go v6 only right up into the point I find a specific flow that I've got to get out into the v4 infrastructure, and then I'll specifically translate that, starting to simplify that sort of broadband access edge to v6 only and just do the v4 translation further in. But I think that's years away.
Well, I would like to follow up on that and come back to my previous point. You're right, if you do that, that somehow simplifies some of the network. However, if you look at the number of IPv4 address that you will put on that box, which is a NAT64 box, and you compare it to the number of v4 address that you will put on the same box that will do NAT44 and by being cascaded NAT, but NAT44, those two numbers will be identical because it's really a function of a number of flows that you have to translate divided by 65,000, which is the number of ports per IP address. Yeah, so that will not reduce the actual number of IP address you need.
Yeah, I agree with you on that. I think the point ultimately, though, is at what point in time can I get away from putting two addresses on a CPE, not through the lens of trying to conserve addresses per se, but through the network simplification aspect. So I agree with you. You run the math and you're going to end up with a similar number of non-unique v4 addresses that you keep just regurgitating over and over again. But that edge infrastructure, living with that as dual stack for forever is expensive. Yeah. And ultimately we're going to want to pull that cost structure out and simplify.
I totally agree with you. This is the point that I was trying to make with IPv6. The economic reason to do this IPv6 work is actually to simplify the network. And it's something that we have learned in the last 10, 15 years is if you look at the cost, the OPEX cost in the network, this is really the dominant cost. And the outage really increases cost. And all those outages are actually root caused by complexity. So if you want to diminish the OPEX, you have to reduce the complexity. And IPv6 is an opportunity here to reduce this complexity.
First, a quick question for Keith. So you guys manufacture a product that does translation from 4 to 6? Okay. So we also heard that translation from 4 to 6 brings with it lots of performance issues, latency, packet loss, problems with multiple video streams, and problems mapping addresses behind it and in front of it. And so why would you develop a product with all those problems, I guess is one way to put the question. Or are you saying that you guys can do this without without that? Or another way to ask it is, how much latency and packet loss and problems would one expect on your 6-to-4 translation?
Yeah. So it's a good question, and it like anything in this world, the answer really is it depends. All right. One of the biggest distinguishers up front is whether or not the particular use case is a stateful versus stateless one. Because as soon as you're having to real-time maintain state and pass it back and forth, as opposed to a stateless, just prepending and postpending off prefixes, it adds to the number of cycles a box needs to do something, and therefore can add the latency. Now, for most client experiences with web-style traffic, meaning anything that we're not talking about specialty use cases like high-frequency trading, the level of latency that's added on a per-hop basis is very, very modest. We're talking measurements in tens of microseconds, hundreds of microseconds, all sub-milliseconds, but like imperceivable, unless we're talking about specialty traffic environments. So that's, I think, one of the comments that I would make. The other one, to your comment on, man, NAT devices always add in complexity. Why would I want to do that? It's a question about alternatives, right? The starting point, I think, for many of the conversations is the ideal world is one in which I've got both protocols flowing seamlessly across my environment. The economics of getting from here to there are daunting. And if we're talking about a circumstance where I've got millions of CPE devices that I've got to go do a truck roll to go and upgrade those devices, that cost structure says, no, I will deal with the challenge that comes with adding an additional point of complexity into the environment in order to manage that piece.
I would like to add to this. We also build those boxes doing NAT 4.4, NAT 6.4, NAT 6.6, I mean, all different flavors. And in the end, that's not that much different from a normal router. It's done on a normal router. It's just a service card on it. And when we do things like MPLS, where we pop label or put another label, it's essentially writing a little part of a packet. And doing that is not that different from that. We need to keep state. Okay, that's why it's done on a service card. It's not done on a line card. But we cannot do those things at line rate. So there's enough hardware that we can forward the problem to really reduce the impact on the application. The challenges are more about how do we operate this thing? What is the control plane, essentially, for those NAT boxes? And that's why we are working in IETF to have those port control protocol and other items there.
From the service providers that I've been speaking with, really people do not want to be deploying this NAT. The problem is, they'll go through everything they can to find other addresses to give to customers, but at some point, there are no more. It's kind of a good problem to have because it means that they're growing very rapidly and more customers are getting use out of the internet. At some point, though, either you have to share an address across multiple customers or you have to tell someone no. And no service provider wants to say no to their subscribers.
Yeah, the only other point that I would make on this, just to put some of this in context, because I know NAT isn't everybody's favorite thing. You got to look at the whole cost structure. So we had, as Brocade IT, had a business driver last August to go and put our public web presences on the public V6 internet. And we're an IT shop like anybody else. We get a pretty good deal on gear, but beyond that, we've got budget constraints and personnel constraints and skill set constraints just like everybody else does. Incidentally, the driver for us wasn't an eat your own dog food driver. We had some friends of ours in the US federal government who were indicating that they were going to exhibit preference during procurement for vendors who actually used their own gear. And like anything, they were going to measure using your own gear in a systematic way. Do you support V6 native web, V6 native DNS, and V6 native SMTP? And if you do all three of those things, we'll trust that your product doesn't just say it does IPv6, but you can actually use it, and we could reasonably be expected to operate it and troubleshoot and all of those other things. we found when we looked at the cost of upgrading, of course, both the guest OS as well as the application, because both of those likely need to go through an upgrade cycle if they're not modern, if you're on running anything on an older OS or an older app infrastructure, to get them v6 ready across all of those different pieces, versus, as admittedly an interim solution, but probably a multi-year interim solution, using our existing load balancing infrastructure in front of those platforms to perform that translation. It was clearly use the translation. 6 weeks and we're done. And 4.5 out of those 6 weeks we're working with our providers in order to get the v6 sort of dual homing to the conversation this morning working right. So is that the permanent long-term solution? Absolutely not. But if we had our public website on v6 for a year now, we absolutely have. And we're very proud of that.
And I think there's other vendors, F5 and other load balancer vendors, and the gentleman from Sonos is doing that with SBC. So it seems like there's lots of good human innovation that's coming out to make this work a lot better. And to me, it's a different message than we're hearing that, well, you're going to have all these problems with translation, so you better get converted. And you know, it causes a bit of skepticism in my own mind when I hear that, and I question it. And as somebody who owns an enterprise network, you know, that's a kind of an attractive solution. Exactly the last thing you described. I mean, that's just going to be a heck of a lot easier than, like I said, we have a web service running on versions of Solaris that don't even support IPv6, just one of many examples. So it sounds like we're getting a mixed message, which I guess is good. That's why we came here. We want to hear both sides. But I just wanted to point out that
yeah, I think the distinction there
contradiction
is that
there.
It's the destination versus the journey. Right, the destination for us, absolutely dual home, dual stack, native support on each of the OSs.
Right.
It's just going to take us a while to get there.
Yep. Thank you.
Okay, I'm getting the nod